So the first thing I'm going to need is help filling out this chart. All right, you don't have to fill it out or you don't have to write it on your own. I just want help filling out the chart, making sure we are solid coming from yesterday. First thing, we found out there are two sets of lines that are concurrent in every triangle. These are always concurrent. These are always concurrent, no matter what the triangle is. So the first thing I want to ask somebody is, name one of the lines that are always concurrent in a triangle. We went over two type yesterday. I just want to know one type right now. Here we go. Whoa, yep. Look at this. Two. We went over two types of lines yesterday that always intersect at the same point, aka concurrent. I don't want to say intersect at the same point anymore. I want to use the word concurrent. Okay, we did a lot of work and we found that the perpendicular bisectors met at the same point. And I don't want to say at the same point anymore. I want to name that point now. So boom, perpendicular bisector number 1, number 2, number 3 are drawn. They all intersect at this point we named. What's going to happen today, huh? Okay, 27. Nope, and look at that. I don't even have a number here. 20, what do we call it? Called the circumcenter. That's the point where all three perpendicular bisectors meet. What's so special about it? The theorem, the fact that I should know going into every quiz, homework, class from now on. What's so special about the circumcenter? 18. I found it. What do I know about it now? Has to do with being equidistant from something in the triangle. Equidistant from the vertices. Done. There it is. There's one set. Then second half of class yesterday, we said, whoa, there are more than the perpendicular bisectors that are concurrent. What else did we figure out was concurrent in a triangle? 25. How about 14? What else is concurrent? Angle bisectors were as well. And instead of saying the point where they intersect, we gave that point of intersection a name for the angle bisectors. 23, in-center. In-center. And then at the end of class, there's a special fact about the in-center, just like the circumcenter. What do we figure out about the in-center? Here you go, 15. From the sides of the triangle, not the vertices, but the sides. And that was yesterday. And if you think it's coming quick now, I'm doubling this chart today. I'm doubling it. So 4 more concurrent lines, 2 more points of concurrency. All right, so you have 4 in total by the end. Buckle up. Any questions on those right now before I get to the homework? Because I am going to refer back to this chart when we go over the homework. Anything you want to ask here? All right, let's go to the homework. I'm sure there was questions here or there. Let's start it off. Where are we going? Charlotte. 27, everyone. Well, first of all, let me just make a comment about 16. If you didn't use a compass on 16, either you were totally clueless that you had to, or you're just plain lazy. All right, I'm sure you know which one I don't prefer. Okay, because I had warned you guys that that first one was going to be a construction, which it was. All right, so whether you chose to do it or not, that says a lot about whether honors is good enough for us or not. All right, 27. Okay, perfect, 27. I'll do 27 and 28 because you can't do 28 unless you know 27. All right, point P is the in-center. You see it's the in-center. 2 things should come to mind. It's formed by all 3 what? And what's the special fact about it? So when you know something is the in-center, a point P is the in-center, first thing that comes to mind is, all right, how was it formed? All three what lines? And then what's so special about it? And that's going back to the chart we just did. So I will take either one right now. 16. So what I want to know is, how's it formed, or what's so special about the in-center? Your choice. Angle bisectors. So that means 3 angle bisectors intersected at point P. Name the angle bisectors on my diagram then. If they all intersected at point P, because that's what in-center is, the angle bisectors, name the 3 segments in that diagram that represent angle bisectors. 8, name the 3 segments. Done. DA, CB, FC. And guys, what do angle bisectors do? Cuts the angle into 2 congruent ones. So if that's 28.5, what's right next to it? And if that's 33, what's next to it? 33. I know this had nothing to do with the problem, but it did when you get down to 29 and 30. Is everybody good? Yes? No? We all right? Okay, because your compass isn't going to help you here playing around with it. All right, so let me get to the other part. Come on, get out of here. Angle bisectors, what's so special about it? That's how I'm going to do this problem. What's so special about the in-center? What's the fact about it? 3, what's so special about it? Okay, thank you. Here you go. 4, what's so special about the in-center? We're on fire today. 18, what's so special about it? Sides. It's equidistant from the sides. So now what I'm going to ask somebody is, name 3 segments that are congruent up there. If P is equidistant from those 3 sides, name 3 segments that are congruent right now. 29. Okay. Name 3 segments that are congruent up there if P is the in-center. Everyone good? There's a lot of power here knowing your stuff. All right. Now let me get to the question, which was 27. What's PB? I did all that hollering and intense stuff up here, and you really needed none of that. PB is part of a right triangle. Does everyone see it? PB is part of PAB. And how many sides do I know of that right triangle? 2. So if I know 2 sides and I'm trying to find the third all year long, we've been using what to find the third? What have we been using all year long? Right triangle, find the third side. Pythagorean theorem. And that's all 27 was Pythagorean theorem. Name one of the sides in that triangle. Name one of the sides in that right triangle. Here you go, 19. Name one of the sides. Okay, that's a leg, so I'm going to go 10.9 squared. Name another side in that triangle. 7. 13. That is the hypotenuse because it's across from the right angle. And then the side I'm looking for, PB, is a leg. So there I go. Does everyone see it's just part of a right triangle? Okay, so we ended up, it looks like 7.1 for that one. I'm going to ask you to do 28 now, if you haven't done so already. Which is find DE. DE is also part of a right triangle. Does everyone see the right triangle with DE? This one right here. Everyone good? How many sides do you know of that triangle? 19. How many sides do you know of that right triangle? 2, even though only one's labeled. So why do we say 2? Even though only 14.9 is labeled, how do we actually know 2 sides? Come on. PB, because it's an in-center and it's equidistant from the sides, PB, which we just found was 7.1, is congruent to PD. So that has to be 7.1. So 7.1 squared plus the other leg equals your hypotenuse, 14.9 squared. Okay. Questions from you guys there now? We all good? Other questions that you had? Let's keep this train going. Other questions you want to answer here? This is not you guys think, oh, no proofs, we're clear sailing. No, this is tough stuff with this new vocabulary. Tough stuff. Yes, Mike. 17. Okay. Same thing I just did in the last problem. Circumcenter. How's it formed? What's so special about it? Okay. Circumcenter. How's it formed? What's so special about it? 13. Either one. What's so special about it, or how's it formed? It's formed by the perpendicular bisectors, yes. And what's so special about it? 4, nope. How about 10? What's the special fact about a circumcenter? Good, vertices, perfect. All right, so let's go over here to the diagram, Mike. I got point D is the circumcenter of triangle ABC. So let me highlight ABC. One more time. And it's looking for, list any segment that is congruent to AD. All right, ready? AD is a what on this triangle, Mike? So according to the circumcenter theorem, D is equidistant from that vertice and also the other two. And what are the other two vertices? DB and DC. Okay, so because AD, that's the distance from the circumcenter to the vertice, it's also congruent to the other vertices. Okay, good. Others? Anything else on the questions you wanted to ask? Going? Yep.
So like in the circumcenter, could there be a triangle that's like a circumcenter?
Oh yeah. What do you mean? They're two different points? Yeah. Absolutely. Yeah, absolutely. Yep. And the circumcenter can be anywhere. Could be inside, could be outside. Yesterday we did a right triangle. Anybody remember where the circumcenter was when we did the right triangle example? Yeah, it was right on it. All right, so circumcenter could be anywhere, outside, inside. In-center, though, think about it. In-center's got to be definitely where? Inside this triangle. It's got to be definitely inside. But the circumcenter could be anywhere, outside, inside, or on. Anything else going? Yes. Okay. You tell me. So remember doing the sink yesterday with the stove, and I had to put the island somewhere, right? Where I have 3 schools, and I want to put bus yard B the same distance from each school. So each school here is the vertice of a triangle that I can form. And what's that point called that's equidistant away from all 3? Circumcenter. So let's keep processing. Circumcenter, so I need the intersection of the what for circumcenter? If I want to find where the in-center is located, I need to find where the all 3 what intersect. What type of lines? Perpendicular bisector. So that was my construction here. Is taking my compass and putting it on one of the sides and doing the perpendicular bisector. Open it up more than halfway. This side. That side, draw it through, and I'll do it for another side. Okay? So that point that's equidistant got to be the circumcenter. All right. Anything else? Yep, Natalie? Okay, did you graph it? Yeah. Okay, what type of triangle did it end up being? Okay. So you had to find the circumcenter, right? Yeah. Okay. So the circumcenters where all 3 what intersect? All 3 perpendicular bisectors. Okay, so you had 2 legs that were horizontal and vertical, correct? Yeah. All right. So what is perpendicular to a horizontal line? A vertical line. Okay, and it's got, what's bisector tells me? It's got to go through the what? The middle. Yep. So here's C. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. There it is. So for the first perpendicular bisector, I go 1, 2, 3, 4, 5. There's the perpendicular bisector. And the same thing I can do for BA, but now I'm going to do a horizontal line. It's at 6. 1, 2, 3. Do I need to do BC? Do I need to do the perpendicular bisector for BC? No. Nope, because I already know where it's going to intersect. Right there. And my only concern is when you name that point, make sure you go from the origin, not anywhere else. Okay, we good, Natalie? Yeah. Okay. Anything else from the homework here? Yes, Marlies. 19. Okay. Let me get rid of all this. So what are you doing? AH? Okay. Again, I know I just erased it, but how is the circumcenter form? All three what? Okay, perpendicular bisectors, which means on this diagram, I am going to have 3 perpendicular bisectors that meet at D. I am going to have DE, DH, and DF are all perpendicular bisectors. Okay, so we're asking what else is congruent to AH? Well, what did we say DH was? A perpendicular bisector, right? Which means it bisects AB. So if AH, what's on the other side? HB. Just because I know that DH is a perpendicular bisector. All right, well, how do I know it's a perpendicular bisector? Because D is the circumcenter. Okay? We are okay there? Anything else? Good questions here. Good questions, because there's 2 more coming today. Okay, let me see it, and then we'll get right into new vocab. All right off the bat, giving you a new vocabulary term called the median. I will let you read through right now, please. Read through what a median is, and then see if you can come up with a true statement about my diagram. All right, so go ahead, read through what a median is, and see if you could come up with a true statement about that diagram, triangle ABC. All right, here's what a median is, everybody. Here's what a median is. It's a line segment. It is a line segment. One end of the line segment is where? On one of the vertices. It has to start at a vertex. It cannot start in the middle or on one of the sides. It has to start at a vertex. And then where's the other end of the segment? The midpoint of the opposite side. So knowing that A is the vertex, D is the midpoint, come up with a conclusion right now about my diagram. 10, conclusion about my diagram. BD equals DC, I like it. BD is congruent to DC. Why? Because D is a what? D is a what? Midpoint, okay. Challenge question. How many medians could I draw in that triangle? The answer is not infinite, by the way. The answer is not infinite. How many medians could I draw in triangle ABC? Only 3. Why? Because where's the beginning of every median? Vertex. So there's only one line I could draw from vertex C, and where's it end? At a midpoint. And there's only one line line segment I can draw from B to the midpoint. And eventually today, what do you think is going to happen to all 3 medians? What's been kind of like the theme here? They're all going to intersect at the same point. All right. So that's a median. And now we bring our attention to what's called an altitude. This you may have heard of before. Sometimes called the height of a triangle. All right. So go ahead, read through what a altitude is. It's slightly different than a median. So it's a segment. Where's it start, the segment? Still from a vertice like the median. But now, where's the other point? On the opposite side, but somewhere on the opposite side, so it's perpendicular. Does it have to be the midpoint? No. That's the difference between these two, is it does not have to go to a midpoint, but it does need to go to a spot that makes it perpendicular to that side. So somebody give me a true fact about my triangle ABC now. If AD is the midpoint, what do you have for me now? Here you go. 2. What do you got for me? They are what? Right angles. I thought you said linear pairs, which is correct, but not what I was looking for. Angle ADB and angle ADC are right angles. Perfect. Okay. So I got medians. They start at a vertice and go where? Medians. They go to where? From a vertice to a midpoint. And then altitude starts at a vertice but is perpendicular to the opposite side. Good? All right, let's test your knowledge now with people around you. Parts A, B, C, and D. I am looking. Segment CD. You can either name it a median, an altitude, or an angle bisector. Neither is not an option on this one. Okay, so people around you, you can discuss it. Name A, B, C, and D right now. Again, CD, line segment CD, what is it? Get after it. What is it? Part A. Part A, what was CD in your opinion on part A? Here you go. 1, what was CD? That's an altitude. Yep, it's perpendicular from the opposite side. Altitude. All right, how about part B? What was CD in your opinion? 12. That is a median. It looks because AD is congruent to DB. D must be a midpoint, so that makes it a median. Part C, what are we thinking about there? Oh, 30. That is an angle bisector. And I don't know if we had a little arguments, controversy with D, but CD in that diagram is going to be 22. That's an altitude. Yeah, think about it. Does it start at a vertice? Check. Is it perpendicular to the opposite side? Check. That's an altitude. All right, still not off the hook. Still haven't proven much to me yet. You and everyone around you. Question 2 on the next page. Question 2. I give you a lot of things here. I gave you an altitude, an angle bisector, and a median. And then I asked some questions off of that. So talk with people around you. Here we go. All right, name 2 congruent angles, but it's got to have a vertex at C. Your angle bisector was help you out here on this one. The angle bisector would have helped you out. What are your 2 angles? 7, what are your 2 angles? ACE and BCE. I like it. Angle BCE congruent to ACE. Don't freak out if you called it, ECB. That's fine. Same angle. 2 line segments that are congruent. The median would have helped you out here. The median. Go ahead. 20. What do you have? Nice job. AF was congruent to FB. Name 2 sides that are perpendicular. The altitude would have helped you out here. Go ahead, 8. Got it. AB, perpendicular to CD. And now building off part C, building off of it, where are 2 right angles? Go ahead, 14. Where are 2 right angles? CDA and angle CDB. Now, maybe some of you may have not called it CDB. You may have called it CDE or CDF. That's perfectly. All good. Medians, altitudes. All right, dig deeper. That's what I meant. Dig deeper into the medians now. Okay, we're going to dig a little deeper into the medians. If you haven't already, go ahead and draw a triangle ABC. I'm going to give you guys same responsibilities as yesterday. I got group 1 over here, group 2 in the middle, group 3 over here. Group 1, when you're ready, find the midpoint of AC for me. Group 2, you got the midpoint of CB. Group 3, you got the midpoint of AB. Add the x's, divide by 2. Add the y's, divide by 2. Hey, group 1. Midpoint of AC? 5, 5. So everyone make sure you jot that down and graph it for me, please. And graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Point D, we're going to call that one point D. And because this is the only time we're going to do it and it's not that far, please make sure you use some kind of straight edge around you and draw in median BD. Draw in the median BD now. All right, next up, group 2, midpoint of CB. You didn't even really need the midpoint formula, but hey, 8, 4. That one was the toughest one probably, right? And we're going to call that point E. And draw in median AE now. All right, guesses here. What's going to happen when we do the third and final median? Don't use that. Don't tell me they're going to all intersect at the same point. They're going to be concurrent. There we go. We're using our big boy, big girl words here. Good job. Group 3. 5, 3. Good. Call that point F. And what do we notice when we use our final straight edge to draw in the median? All 3 medians are. All 3 medians are concurrent. You're darn right they are. So now if I go back here, looks like we have another pair of lines that are concurrent in a triangle. So a third pair. Now we need a point of concurrency. A special name. You guys see it right below. Let it roll off the tongue if you want. Centroid. The centroid. Nice little name. So what's the centroid? That's my point of concurrency for what? The medians. Point of concurrency for the medians in a triangle. Centroid. So we can add that to the list, right? So guess what else now we got to figure out? What's so great about it? What's the factor of the theorem about it? All right. This one's pretty important. Not that the other two weren't, but. All right, you're ready. I'm just going to give it to you, and then we'll explain it using the graph. The centroid breaks every median into a ratio of 2 to 1. Woo! All right, what do I mean by that? All right, go back to your graph, please. I'm going to ask somebody right now, name one median in our graph. All right, name one median in triangle ABC that we had. Here we go. Oh boy, yep, this is fun, real fun. 25, all that suspense for nothing. 14, name one median I have up here. DB, perfect. All right, ready? This is what this 2 to 1 theorem is saying. DB, do you see? I'm going to call the centroid G. All right, I'm going to call that G. Do you see that median DB is broken up into two segments with the centroid? It's broken up into GB and GD. Everyone agrees. All right, here's what that 2 to 1 means. That means that BG, the segment from the vertex to the centroid, is twice the length of DG, the other part. One piece is double the other. All right, that's what this theorem is saying. BG is twice the length of DG. Which one's the bigger piece? The piece from the centroid to the vertex is always the bigger piece. Knowing that now. 19, name another median. AE. Name the bigger piece of AE. Name the bigger segment of AE. AE is broken up into GE and AG. Which one's the bigger one? The one from the vertex to the centroid, which is named what? Okay, let's back up. Name a median for me. AE. Do you see how AE is broken up into two different segments? AG and GE. We good? Which out of those two is the bigger one? AG. So we can say AG is twice the length of, which one's the smaller one? EG. Everyone seeing how this is working? The centroid breaks it up into 2 to 1 ratio. One is double the other. Questions before we start applying some algebra to it? All right, let's see if we can work it now. Here you go. M's the centroid of WOR. WM is 16. Remember, M is the centroid. WM is 16. What's got to be the whole median WX? 2 to 1. Okay. 4. Nope. On fire. Yep, on fire. 5. Hold on. 32. Hold on. Before we even get, what's MX? Before I get to WX, what's MX? 8. Now you put the both together and you end up with 16 and 8. What's the whole median? 24. Everyone see how she got 8? W to M is twice the length as M to X. Okay, YM is 12 now. YM is 12. I need to find YO, the whole median, and MO, the other part of it. I am going to start with MO. Centroid. 7. What's MO have to be? 24. Double it. 2 to 1. That's where that comes in. 2 to 1. And then, Aaron, just keep going. How about YO then? 36. Good. Questions there? before we get into an actual algebra one using this. Because now I don't want to use numbers. Now I'm going to use actual expressions. All right, read through this, because I have a huge issue right off the bat. Nowhere in this problem does it mention the word centroid. How do I know I'm dealing with one, though? How do I know that G has to be a centroid? Has to be, even though that word never pops up in the problem. 5, how do I know? Medians. They're all medians, which means in my head, medians all intersect at the centroid. So that must mean G is a centroid. So now I'm thinking 2 to 1, 2 to 1, 2 to 1. That's 2x plus 10, BG. EE, 3x minus 1. All right, what am I doing with the 2 to solve for x? Because this is not correct at all. You trying to set them equal, no chance. It didn't say 1 to 1, I said 2 to 1. Did not say 1 to 1, said 2 to 1. I'm going to need somebody to adjust that equation for me so I can solve it, because it cannot be solved right now. Incorrect. Someone want to adjust it so it fits the 2 to 1 theorem. 21. Speaking of 2 to 1, everyone see that one? Yeah. 21? Do we have a 21? Okay, all you have to say is not here instead. I'm just looking around doing bad jokes. 19. I double the smaller side, or if you're really feeling frisky, what could I have done with the larger side? Take half of it. Yep, so go ahead, solve that for x. We got plenty of time. Solve it for x. And then let's actually answer the question, because the question's not solve it for x. Everyone calm it down. We're fine. Anybody coming up as you're finishing the value of x? 3. Go ahead, plug it back in to get BG and GE. Actually, we just needed BE, huh? Well, you need both anyway, but BE, what do we end up with for BE? 24 units. Yep. I will go over that last page first thing tomorrow. I'll be here today after school if you want to stop by to go over anything.